Hello and welcome back to another video. Today we will be looking at the grade 10 chemistry paper. Question 5.1. Calcium reacts with chlorine to form calcium chloride. 5.1.1. Write down the number of electrons in each Ca2 plus ion. Okay, so let's just quickly recap what an ion is. An ion is an atom that has lost or gained electrons. Now, if it lost electrons, it's going to have a positive charge. If it's gained electrons, it's going to have a negative charge. So Ca2 plus tells us that it is a calcium atom that has lost 2 electrons. So calcium has 20 electrons minus the 2 that is lost. That means it's going to have 18 electrons left. So 5.1.1. Question 5.1.2. Draw the Aufbau diagram and provide the electronic configuration for chlorine. Let's go and check. Chlorine has an atomic number of 17, which means that it has 17 electrons, or there are 17 electrons in an atom of chlorine. So chlorine, there are 17 electrons for us to fill. We always start with the 1s, then we go up 2s, 2p, 3s, 3p. Now we know that the 1s is always one block. The 2s is also one block. 2p is 3 blocks. 3s is 1 block. And 3p is 3 blocks. And each block contains or can fill or occupy 2 electrons. We have 17 to fill. So we start with the 1s. So half an arrow pointing up, half an arrow pointing down. That's Pauli's exclusion principle. Then 2s, 1 pointing up, 1 pointing down. Now 2p, when we fill the p orbital, you fill 1 block each. That's called Hund's rule before pairing it. So far we filled in 10. 11, 12, 13, 14, 15, 16, 17. Now if we want the SP notation, all we need to do, write out the orbitals that we've used. We've used 1s, 2s, 2p, 3s, 3p. And then as exponents, write down the number of electrons that were filled. So 1s we had 2, 2, 6, 2, and then 5. So that's our answer for question 5.1.2. Question 5.1.3. Identify the type of bond that forms when calcium and chlorine combine. So calcium is a metal. It's found on the left-hand side of the periodic table. Chlorine is a non-metal because it's found on the right-hand side of the periodic table. That means we're going to have an ionic bond that forms. Next question, draw the Lewis structure for calcium chloride. Okay, so since it's ionic, let's revise our ionic charges. Group 1 will have an ionic charge of +1, then +2, then this will be +3. We skip group 4 or 14, then -3, -2, -1, and 0. So calcium chloride, so calcium is in group 2, so it's going to have a charge of +2. So Ca2+. Chlorine is in group 17, so it's going to have a charge, or group 7, so it's going to have a charge of -1. It's best if you just learn the charges. So Cl is -1. Now, those exponents don't cancel each other, so we need to cross multiply. So I'll take the 1 from here and I'll bring it down here, and I'll take that 2 and bring it down there. So the formula is going to be Ca Cl2. We don't need to show that 1. So how do we show the Lewis diagram for this? So the Lewis diagram will look like this. So you're going to have calcium without any electrons. It lost both of its electrons. And then you'll have a chlorine on the left-hand side and then a chlorine on the right-hand side. Now remember, chlorine has 7 valence electrons. So 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. And then each chlorine had taken 1 electron each from the calcium. So there's going to be 1 electron from the calcium that's there and 1 electron for the calcium that's there. And now the charges are going to be each -1 and -1. And that's our answer. Okay, question 5.2. Copper has 2 stable isotopes. Copper 65 has a percentage abundance of 25%. The relative atomic mass of copper is 63.5 AMU. Determine the number of neutrons in the most abundant isotope of copper. Okay, so we don't know what the other mass is, right? So that's the first issue. Let's look at how we can solve this. So there's going to be 2 abundant isotopes. So you have copper 65. That means it has a mass of 65. And they tell us that the percentage is 25%. Now there is another copper. We don't know what the mass is. So let's call that copper X. Its mass is going to be X. And its percentage we do know. Because remember, the total percentage must equal 100. So it means that this other one must be 100 minus 25, which is 75%. Okay? Now we know that the formula to work out isotopes is the following. So we can take the mass. So let's set it out. So we'll say the mass of the first one, so 65, multiplied by its percentage, plus the mass of the second one is X, multiplied by its percentage. So that's the first one, that's the second one. That's going to give us the relative atomic mass. Now we know the relative atomic mass. They've also given that to us. So they've given us the mass as the relative atomic mass is 63.5. So 63.5. And now it's just a matter of solving for X. And when you solve for X, you get that X is equal to 63. Right? So remember, this is not the final answer, because the question is asking to calculate the number of neutrons in the most abundant isotope of copper. So remember, the number of neutrons is equal to the mass minus the number of protons. And we know the protons is the atomic number. Now we worked out the mass to be 63. Let's check the atomic number for copper. The atomic number for copper is 29. So the number of neutrons is going to be 63 minus 29, and that gives us an answer of 34 neutrons. Okay, let's move on. Question 5.3. Write down the chemical formula for magnesium oxide. Now, let's just make sure. Magnesium is Mg, and oxide is oxygen, which is O. Magnesium is a metal, oxygen is a non-metal, so it's going to be an ionic compound. Magnesium is in group 2, so that's going to have a charge of 2+. Oxygen is in group 16 or group 6, so that's going to have a charge of -2 or 2 minus. The exponents cancel, so the answer is simply going to be MgO. Let's move on. Ammonium dichromate. Now, ammonium is NH4 plus. It's a polyatomic ion that you need to learn. And then dichromate is Cr2O7 2 minus. That's also a polyatomic ion. These exponents do not cancel. This is a +1 and that's a -2. They don't cancel each other. So we need to switch them. So that will go there and that will go there. Now remember, there is a rule that applies here. When you are cross multiplying like this, and if you are using if there's a polyatomic ion involved, like there is here, you need to use brackets. So NH4, you can't write NH4 2, because that's incorrect. Doesn't make sense. You can't write this. This is not the answer, because this could be misinterpreted as 42. That, like, what does that mean? So that's why when you are cross multiplying and there's a polyatomic ion involved, use a bracket. So that's our answer. Okay, next one, write down the chemical name for CuNO3 2. So Cu is copper and NO3 is nitrate. But we need to be careful here, because copper is a transition metal. If we go down here and see, copper is a transition metal, meaning that the oxidation numbers can vary. The exponents, the charges can vary. And it varies depending on a number of factors, but one factor is what it's bonded to. Okay? So nitrate, if we consider this, right? Copper is going to be Cu something, right? Nitrate, we know, is NO3 minus 1, right? Now, if our answer was this, CuNO3 2, if you wanted the exponent or the oxidation number for copper, all you need to do is undo the cross multiplication, because there's a bracket involved here. That means there was cross multiplication that was involved. So to undo it, just take this 2 and bring it to the top. That means the charge was 2 plus. So to write out the answer, the name of this is going to be copper, and in brackets we will write down 2 in Roman numerals, and then nitrate. So that's our answer. Okay, if you like this video, please consider subscribing, leaving a like. If there's something that you wanted me to do specifically, some paper, some question, please let me know down in the comment section below. Bye-bye.